Hello everyone, my name is Anthony Shivkumar, and in today's video I want to talk about the Freedom Motor Control LVBLDC from NXP. So this is one of the development boards that allows me to test a brushless DC motor using the KV3X, which is one of the Kinetis microcontrollers that NXP provides. If you have seen the trend on my videos, I'm doing a lot of brushless DC motor control. So I'm testing different development boards. Some of them have blown up, and the reason now I more or less understand what's really happening and why they're blowing up. But yeah, so these are the development boards where I'm testing some of the algorithms. Some of them are basically done by the manufacturer itself, and I'm trying to select which pre-driver and configuration would work best for my drone. So what I have in here is the NXP Freedom Development Board. It's the MV Motor Control LVBLDC. So let's open it up. This is the microcontroller that we are supposed to use in order for us to test the motor control LVBLDC. So in here you get a package of basically what the pin diagram is. And we have over here what's in the box basically. So let's open this. And yeah, this is the motor control BLDC driver. And what we're going to do right now is we are going to basically mount this onto the KV3X. So let's have a closer look at what's there in the KV3X. So this is the KV3X, and this has basically got the same layout as the Arduino. It's got an accelerometer, a couple of LEDs. So the development board has a couple of peripheral accessories that allow you to test different algorithms. But one of the things we'll be doing today is basically mounting the LVBLDC on it, and we'll be using one of the custom codes that NXP provides in order for us to test this configuration. So what I'm going to do is mount this So here we have this mounted right in here, and the pin layout and pin diagram the pins will automatically be connected to the corresponding pins on the MC-BLDC. So this basically the stack up automatically connects the pins. I don't need to use a breadboard, and I don't need to use a wire. So that's the advantage of using these types of generally these types of boards. Okay. So next, let's go to the software. When you go into here they have an HTML documentation. We can click on this. And in here, they basically tell you how you want to stack up. This is for the LV motor. Here they tell you can use the KV10 or you can use the KV11. And once you download one of the software, then we can basically run it. So I'm running this on the Kinetis Studio. So I've already downloaded the code. So when you download the package, it will basically download all of these files. You can go to source, and then you can go to projects. The one that we're going to use is the Freedom KV31F, and once I know where the location of my files are, I basically bring it to the Kinetis Studio. Where's my Kinetis Studio? I might have closed it. So you open Kinetis Studio. I can click. I'll rather use this under C drive NXP. It's either one of those two workspace. In the meantime, what we have over here, let's basically get the connections working. So I have the 3 wires to connect to the motor over here. So this will be one of the motors on the drone. It's a brushless DC motor. It can work with the power source where we have the battery over here. So all right, so all the 3 wires are connected. What I have over here is a plug that can allow me to connect this to the battery. So all you got to do is wait, I might have had the I might have the wrong configuration. You can buy one of these plugs from Amazon. So it basically allows you to plug this into here. And what I'm going to do is now basically connect the positive to the positive, negative to the negative. So the way this is connected is that this is positive, but the way this works is that it goes from red and then it goes to black. So black is technically positive on this end. It's just the way the plugs are connected. Just need to make sure that there's no short circuit. I'll leave the wires in there. All right. So Right, the next thing is we need to connect the USB. Get my USB drive, the cable I need. And we'll configure it, and then we'll download the code. Instead of doing that, I'm just going to make an extension. Clear what I don't need. Perfect. A lot of wires. I'm just going to clear this. It's starting to get messy. So let's clear everything. Okay. And here we go. So the green light is on. You can see the green light over here is on. I'll connect the brushless DC motors. One over here. One over here. And what? One over here. Perfect. All right. So now let's install the code. So the kinetis, I'll just allow. So once you plug in the KV31, you'll get this Freedom KV31 opened up in your computer. Now we have it. So yeah, I've opened it's a different space. So I'll just go to C drive NXP. It will reinstall, it'll switch the workspace, and then we'll download the code, and then we'll see if it works. Let's go to the instructions to see what we need to do. To spin the motor will start spinning when pressing user buttons SW2 of the Freedom microcontroller. Plug a 12-volt 5-amp power supply to the power panel connector. So yeah, it says you can connect a 12-volt 5-amp power supply. I'm going to connect 7.4 volt and see if it works. The reason being is because this motor is a 2S motor, and this is a 7.4 volts battery supply. So we'll see if it works, and if it doesn't work, I can change my configuration. But for now, let's see if this works. All right, so this is the code over here. This is the BLDC motor, and so when we go to the source, we can go to the main. Let's go right on top. It tells us over here the main file of sensorless BLDC motor control application for the Freedom KV31 and Freedom MC-LVBLDC. So this is the code. I'm going to build it. I'm also going to open MCU Expresso, because that is generally how I can install the code into here. So it built, and if we go to release, we have the ELF file over here. So this is the executable binary. And I'm getting the MCU Expresso ID to start shortly. So this is another document of the BLDC that when you download the from the website, it just tells you what all boards are compatible with it. So we're using the KV31. Actually, we're not using this one. We're using the Freedom KV31. And how to compile and how to use the project. So yeah, now that we have this, I'm just gonna see what's happening with the McuXpresso ID and as administrator. Yes. Launch. All right, yeah, it's launching. Yes, okay, now it's launched. Where is it? Rather, it's launching. So we'll download the code, we'll plug in the battery, and let's see if it works. So what we got right now is I'm also going to basically enable this as well. So I am going to select the MCU. Let's see where this is installed. So let me go in here and see where this is installed. C drive NXP. So I can just search again. Okay, so it's not okay. Here we go. So that means it's recognizing the board over here. So I'm just going to click OK. I'm going to go to a file system. I'll go to C drive NXP. This is a Windows machine. So just have to go in here, click C NXP. Okay, so it's going to be C NXP. All right, there we go. And we have this under the MCRC BLDC. Source should be under source projects, Freedom KV31 board. Wait, no, it won't be Freedom. It will be, yeah, it's Freedom KV31F. Okay, where are we right now? Wait, I'm missing something. So BLDC ref sol. So which is my workspace right now? So it should be in what? So it's NXP MCRC BLDC v1.2.0 source. Okay, and where is this one? BLDC build ref solution. Got it. So here is gonna build ref solution KV31F kinetis release. Here we go. And ELF. Okay, and then let's click open and let's click run and let's see if it's programming. Yep, it flashed a little bit and it should be working. Okay, now let's connect the battery. The wires might be loose a little bit over here, so I just need to make sure there's no short circuit. Yeah, these wires are not the best. I need to just make sure that there's alright, and then I'll restart the algorithm and then let's see if it works. Okay, so one of the things I need to do is make sure that we are getting 12 volts. So we have red going to red, it's going in here, and just want to make sure we have this. Okay. Alright, so I think I made a mistake. Yeah. This is a mistake. I will disconnect everything. I think I made a mistake. Yeah, so the color was wrong. This is the plus. This would be the negative. No, wait. This is plus, this is plus, plus goes in your black, negative is red. Yeah, there's a color coding issue. Yeah, this is very annoying. I need to fix this so that I can continue to make mistakes like this. This color keeps swapping. And let me connect this in here. Once again, connect the USB. Let me connect in here. Just put this in here. Make sure we have the plus, so it's plus going in here, plus, 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 plus. Negative is the black, negative is connected in here. You can basically insert it. Right, maybe I should disconnect this. So the thing is on. So it's definitely on because that's coming from here. Like if I disconnect, this is off. So that means the power is definitely reaching. But so what I can do is basically swap one of this and see if it works. Okay, so that means it does require 12 volts. So what I will do is just check, I will disconnect everything in here. The battery might be low as well because I have been playing around with it. So maybe needs charging. In the meanwhile, I'll connect it using my power supply. I can basically remove this I'm going to connect this to 7.4 volts. All right. I will disconnect this and connect 12 volts to this. $12.23 volts. All right. So maybe if I swap one of this, so that means it's somehow working. So that's good. So it needs 12 volts. So what I'll do is just swap one of this with this and see if this works. Okay. So I don't want to blow up this yet because this is rated at 12 volts. And this might be at most 2S or 3S. 2S as in, so this battery pack is 2S. That means each cell is 3.4 volts or 3.8 volts, I think, or 3.7 volts. If you have 2S, then it'll be 3.7 into 2, that's 7.4 volts, and then it'll be 11.4 so that'll be 3S. So as you can see, it's starting to basically activate the motor, but it's not completely spinning. I do have my thermal camera as well. I'm afraid I can just try again. Yep, so I don't want to once again spoil the system, but so the algorithm basically works. Let's have a look at what the algorithm is actually doing to get a sense of the application itself, at least in a high level. So this is the algorithm for the no, this is not the algorithm. This is the algorithm for the KV31 MV-LVBLDC. There are a couple of settings. So here we initialize the application port, the motor driver, the free master SysTick, R LED on and green LED off, set the application switch, demo mode, enable interrupts. And then we have the free master polling, and here we have ADC, high priority fast control loop. So we're clearly not even spinning, so there's no fast control loop. FDM is a flex timer 1 interrupt handler. So this might be either controlling the PWM or the switching frequency, or switching the switching frequency, rather the switching phases. This is the flex timer 2. It's a low priority slow control loop, and this is the forced commutation control. So yeah, this will be the switching phase for the timer for that. Then we have here the PDB, which is the interrupt service routine, and it will I'm not too sure what it exactly does. So the port A interrupt handler. So yeah, so the port A interrupt handler, I believe, is either the green LED or the right LED, is the left button or the right button basically. Seconds have passed. Of demo mode, green LED off, R LED on. There's green LED on, R LED off. Demo speed simulator, demo speed stimulator. All right, so we would go to these are the state machines. For the stop, the initialization, the fast. As you can see, controlling a brushless DC motor is not straightforward. I mean, there's a lot of code in terms of activating the pulse width modulator, switching frequency, the timer, the interrupts. So generally a processor you'll technically just use one processor just to control one motor because of the amount of computation it needs to do to just make the motor spin. So it's not easy in that sense. This is the state machine for I guess this is the M1 state BLDC. So yeah, some of them will be basically trying to switch. I'll have to do a deep dive into the code just to get a sense of what they're really doing. For the most part, high level, I technically understand what's going on, but it's good if I can, put some debug pins and see if it all works. But for now, run spin fast. All right, so let's try it again. I'm just going to basically try my luck again. I'm going to put this at it's 12.2 volts. So yeah, it spins. And I don't want it to blow up, so because these things just blow up, they draw a lot of current and then it ends up blowing up. So I'll have to basically figure out why is it not commutating properly. I did switch a little bit. Maybe I'll try switching once more. So this goes here. Let's try one more. Maybe try this here and maybe this here. Let's try. Yeah, so yeah. All right, thank you for watching, and I will see you next time.